All right, this is the fourth and final video for section 4.3 in the AP Calculus on concavity points of inflection. And so we're going to be looking at example 7 here, where we are given information rather than from a graph or from an equation for a function, we're given information in the form of a table. And we're going to make sense of that information to answer some questions. This also is a great response question. So we have a function f, which we know is continuous, on its domain of a closed interval from -2 to 4. F of -2 is 5, f of 4 is 1, and f prime and f double prime have the properties in the table. So I know that down here in part C I'm going to have to sketch a graph of f, so I'm actually going to go ahead and I'm going to plot those specific points that I know are on the graph of -2, 5, and 4, 1. As far as how the rest looks, we'll have to figure that information out from the table here. So my table is chopped up into intervals and into specific x values. So I'm just going to kind of read through it. We know that f prime from -2 to 0 would be positive. At x equals 0, it does not exist, so that means that I have a corner or a cuff or a vertical tangent. I do not have a discontinuity there because they told me that my function is continuous, so I can rule out a discontinuity. From 0 to 2, my first derivative is negative. At x equals 2, my first derivative is 0, and then from 2 to 4, my first derivative is negative again. So what I can tell about my original graph is that my original graph is increasing from -2 to 0, decreasing from 0 to 2, and continuing to decrease from 2 to 4. From the second derivative is also positive from -2 to 0, so that means that my graph is not only increasing in that interval, but it's also concave up.
Eric Watley.
In the second interval from 0 to 2, my second derivative is still positive, so it would still be concave up. And then from 2 to 4, my second derivative is negative, so my graph would change to being concave down. So here's a couple things that I know. A says to find where all absolute extrema of the function occur. So my graph starts at the point -2, 5, and it increases to when x is 0. I don't know where the y value is, but it increases. Then it decreases from 0 to 2, and then some more from 2 to 4. So what that tells me is that my beginning point of -2, 5 is a relative minimum. Now, they only asked me for the absolute extrema, but I'm just kind of making a list. So it can't hurt to include it, even though they didn't ask for it. So then I increase to where x is 0. So that would make x equals 0 the absolute maximum, because we never increase again after that point. I don't have a y value to include, so all I can say is that it occurs at x equals 0. Then I'm going to continue to decrease from 0 to 4, so that actually makes the 0.41 an absolute minimum. All right. I think it might also not be a bad idea to maybe kind of sketch my graph based off the information I have in my table, because that'll kind of help make part A make sense, and it'll also help with part B. I'm actually going to kind of do part B first here, and then we'll go back and revisit part A to make sure it makes sense to everybody. So looking at the chunks of my table, my first interval from -2 to 0, I need a graph that's increasing and concave up. And like I already said, I don't know the y coordinate at 0, so I just need a graph that starts here at -2, 5, and it increases and is concave up until it gets to where x is 0. And I'm going to kind of extend my y-axis there so you can see. So I have increased to where x is 0. Then at x equals 0, I'm going to begin to decrease, but I'm still concave up until x equals 2. Again, I do not have a y coordinate at x equals 2, so I just need something that's decreasing and concave up. So maybe something like that. And then at x equals 2, I switch to continuing to decrease, but now being concave down. So something like this. That also tells me that because my concavity changes, this is where I have a point of inflection, is at x equals 2. At x equals 0, my concavity did not change, so it is not a point of inflection. So if you look at the picture we've drawn, that kind of helps us with part A there. I can tell that x equals -2 is a minimum because we increase past that point. However, it is not the lowest point of the entire graph, so it's only the relative minimum. At x equals 0, I put that peak up there, so that's my absolute maximum. And then at x equals 4 is the lowest point of the graph, so that's the absolute minimum. Then for part B, for the points of inflection, I already addressed that a minute ago, up here from the table where the concavity change tells me that at x equals 2 is where I would have the point of inflection. So sometimes doing things in the order is not necessarily the best thing to do. Sometimes doing maybe part C will help you with answering part A and part B. So that wraps up example 7. There's just a couple of AP practice problems at the end of your notes there. So if you'll take just a few minutes and give those a try, that'll really kind of help summarize the entire section here for you.